Hello everyone, this is the model answer for the density higher exam question. A student wanted to determine the density of an irregular shaped object shown in figure 1. Plan an experiment that would allow the student to determine the density of the object. Okay, so this question is about the density required practical. In this practical, you used a displacement can or a Eureka can to measure the volume of an irregular shaped object. So if you remember doing this, you filled the can up with water to just below the spout. Then you drop your object in. As it goes in, it displaces some water, which then rises up and falls down the tube. You then collect this water in a measuring cylinder, and the volume of water that is displaced is exactly the same as the volume of the object that you dipped in. Okay? The other thing that we need to work out density is mass. So in your experiment, you would have had a top pan balance and you would have put your object on the balance and then you would have got a mass recorded in grams. Okay? So the first thing we're going to do is we're going to show the examiner that we know what the equation for density is and we know how to calculate it. So density equals the object's mass divided by the object's volume. Okay, and then we're going to tell them how we're going to measure each of these things. So for mass, we're going to measure the mass using a top pan balance. Measure the object's mass using a top pan balance. Or scale. Okay, so that one is quite a simple one, the mass, that's quite an easy one to do. And then what we're going to do is we're going to tell them how we're going to do volume. So we need to write down like what I said before about using the Eureka can. Okay, so we're going to fill our displacement or Eureka can with water. And the water level must be up to the spout. So water must be level with the spout. If it's not up to the spout, then it won't give us the correct reading for the volume of the object. Okay, place the object in the water. We then will see some of the water running out of the tube, and we need to make sure that we don't lose any of that. So we are going to collect the displaced water. Displaced is a really good word to use. Okay, so if you can get that keyword in there, we'll show the examiner that you know what you're talking about. The displaced water is the amount of water that the object has shifted or moved out of the way. Okay, and then it's no good just collecting that water because we actually need to use it to measure the volume. So we need to put in the piece of equipment that we'll use to measure that volume, and it's going to be a measuring cylinder. So use a measuring cylinder to determine the volume of the displaced water. Okay, and then like we've already said at the top, once we've got that mass and that volume, we would do that division and we were able to calculate the density from that. So well done if you've had a really good go at that question. It's quite a nice required practical, that one, to be honest. On to the next question. Another student did a similar experiment. He determined the density of 5 common plastic materials. Table 1 shows the results. You've got acrylic, nylon, polyester, polystyrene and PVC. Figure 2 shows the results plotted in a bar chart. Okay, so we've got acrylic, nylon, polyester, polystyrene, PVC. It's a bar chart because these are not continuous variables, these are discrete or grouped data. You will notice on the side that we don't have any numbers on the scale. So when it's telling us to complete figure 2, it's going to ask us to write the correct scale on the y-axis, and it also wants us to draw the bars of polyester, polystyrene and PVC. So let's have a look at this scale. We're going to use the clues that we've got to try and work it out. I know that nylon, this is my easiest one because it reaches a full square there. The nylon is 1000. And then I've got here that acrylic is 1200. Now the space between them is 4 little squares. So that means that 4 little squares is 200, or 2 squares is 100. Okay, so using that scale, what I can do is I can work it back. So I know that 1 full square here, so that's made out of 10 little squares, is worth 500. And then that at the bottom is 0. Okay, so because that's 1000, that's 500. The next one there will be 1500. Okay, so we can use those clues to work out our scale there. We need to put polyester in. Now take note of the location of these bars. We want to make sure that they are the same width away. So here we've got 6 little squares in between them. We want to have 6 little squares in between the next one. So 1, 2, 3, 4, 5, 6. And it looks as if it's about 4 thick. Okay, we want to keep things nice and neat. We don't want to just draw them in anywhere. We want it to look good. Okay, now the polyester is 1380. So that's my 1000. That's my 1200. Another 2 squares will be 300. And then it's 80. So it wants to be about there just before I get to 1400. Okay, so it will help if you have a nice sharp pencil for this. Better than the pen that I'm using. And then you must complete your bar. Okay, nice and neat. Okay, lovely. And then we're looking at polystyrene again. Let's have 6 little squares in between and let's make them 4 squares wide. Now polystyrene is just above 1040. So that's my 1000. That would be my 1100. So I want it just below that line there, just below halfway between them. Again, nice sharp pencil would be very beneficial to you. And then complete our bar, nice and neat. Okay, lovely. And then we've got the last one, which is PVC. Again, we want 6 little squares in between and 4 squares thick. This is a nice easy one. It's 1100, so 1000 is there. And then I want 2 little squares above. Nice and easy, that one. Draw your line down to match it up. That's your PVC. Perfect. Okay, now that is a really, really wonderful for 4 marks, especially for a higher question. Okay, so let's have a look at the next bit. C. The student is given a piece of a different plastic material. The student determined the density of the material 3 times. Determine the uncertainty in the student's results. Okay, so when we're doing uncertainties, what we need to do is we need to look at the range of the data. So think back to maths. Range is your biggest number, take away the smallest number. So it's 1,120 minus 960. Okay, so remember definitions, these mathematical definitions, they definitely do come in handy, especially when you're doing physics problems like this. So if you do 1,120 minus 960, you will get 160. So the range actually is 160 kilograms per meter cubed for the density. Now, because that's our range, that's the difference between the highest and the lowest points. If we divide that by 2, we'd actually be somewhere in the middle of that, which means that the uncertainty would be the difference between the middle of that and each side. So the way that we work that out is to do our 160 divided by 2, and that gives us 80. So the actual uncertainty is 80, and it's plus or minus kilograms per meter cubed. So in my first result, I've got a density of 960. The uncertainty in that is actually plus or minus 80. Okay, so well done if you managed to get all those right. Some of those questions were slightly tricky. Thank you so much for listening to the video and for doing your own self-assessment. Well done. If you need anything, please send me an email and I will get back to you about it. Thank you.